So now let's take a look at compound interest. Compound interest is used for loans or investments of more than 1 year. As the loan or investment is compounded, the amount of interest increases. Let's suppose we have an investment of $100, and that's at an 8% annual interest rate compounded semi-annually. Semi-annually means twice a year. So I've worked up a table here so we can see what's happening throughout this loan. So after a half a year, we get $100 plus 4% of the $100. It was an 8% annual interest rate, but when you compound it semi-annually, you only get half of it. So we only get 4%. 100 plus 100 times 0.04 is $104. In the next half year, we're going to start from $104 and we're going to get 4% of 104. So that gives us $108.16. In the following half year, we start from $108.16 and we get 4% of $108.16 for a total of $112.49. Then we start with that 112 in the next period and get 4% of 112.49, and that gives us a total of $116.99. What you'll notice is this second piece here is giving us our interest, and because we're earning interest, our account's getting larger, which means we're getting more and more interest each time. We're getting 4% of larger and larger values. That's what's meant by compounding. So let's take a look at that first term again. It's at 100 plus 100 times 0.04. If we factor out that 100, that's the same as 100 times 1 plus 0.04. This is just a little bit more convenient way of writing it. If I do the same thing to the next term, I'll notice that both terms there have 104 in them. So when I factor out the 104, I get 104 times 1 plus 0.04. Do the same thing for the next one. We get 108.16 times 1 plus 0.04 and 112.49 times 1 plus 0.04. I think if you look at that, now you'll see what the pattern is. There was a mechanical pattern last time, but now you see that each period, so each half year, we're multiplying by 1 plus 0.04 or 1.04. So if we start at 100, multiply by 1.04, we get 104. Multiply that by 1.04, we get 108.16. If we multiply that by 1.04, we get 112.49, and that by 1.04 gives us 116.99. Now let's go one step farther. Notice that the 104 in that second term at the end of 1 year, well, that was just came from 100 times 1.04. So if I replace the 104 with what I had in the previous step, I get 100 times 1 plus 0.04 squared. That tells me that you get to the end of the first year by starting with $100 and you multiply by 1.04 twice, because there's 2 periods because we're doing this semi-annually. We could do the same thing to after 1.5 years, that would be 3 periods. To get to that, we would have to take the 108.16, we'll replace it with what it was in the second step here, which was 100 times 1.04 squared, and when we do that, we get 100 times 1 plus 0.04 cubed, meaning that to get 3 periods out of this, you have to go 100 and then multiply by 1.04 3 times. If we do that for 2 years, that would be 4 compounding periods, so that would be 100, the original amount, times 1.04 to the 4th power. So the pattern here is each time you compound, you multiply by 1.04, so we get a higher and higher power. And that'll lead us to our formula for compound interest. So the future value A for compound interest is given by this formula. A equals P times the quantity 1 plus I raised to the n. So P is our principal, I is our interest rate per period, and we'll get that by taking the annual rate and dividing it by how many times we compound in a year. N is the number of times we compound during the period, so that's the number of times you compound a year times however many years. Let's go ahead and try this in an example. So what is the future value of a $5,000 investment that returns 12% annually, that's compounded monthly, but for 5 years? If we're going to do 12% annually, compounded monthly, the information we have is that P is equal to 5,000. Our interest rate per period is 12% divided by 12, so we get 1% each month. And if we're going to do this monthly over 5 years, we're going to do it 60 times. Now I put that into my compound interest formula. I get 5,000 times the quantity 1 plus 0.01, that quantity raised to the 60th power. So that's $9,083.48. Although it may look like there's a lot to memorize here, you really don't have to do too much. 5,000 is the principal, that's what you're starting with. You're going to multiply it by 1 plus whatever the interest rate is per period, and then you raise that to however many periods you're going to be doing, in this case 60. Now in some problems we won't have just things on the right hand side of the compound interest formula. Let's look at an example like that. So at what interest rate, annual interest rate that is, should you invest $1,200 for 2 years compounded quarterly to end up with $2,000? In this problem we have the principal, $1,200, but we also have the future value, $2,000. And we're going to do that 8 times over a 2-year period. So let's go ahead and start out with our compound interest formula, but now we'll have to put in A, P, and N. So A is 2,000, P is 1,200, we get 1 plus I to the 8th, so now we're going to have to solve this for I. To isolate that piece that has I, the first thing I'm going to do is divide both sides by 1,200. So that gives me, on the left-hand side, 2,000 divided by 1,200, and on the right-hand side, 1 plus I, that quantity, raised to the 8th power. This is the point where people usually run into trouble because they don't know how to get rid of that 8th power. Well, if it was a square, you'd square root it. So what we're doing is we're going to 8th root it. So we'll take the 8th root of both sides. So we'll get the 8th root of 2,000 divided by 1,200, and the 8th root of our 1 plus I to the 8th power. The 8th root and the 8th power kill each other off, so we're left with the 8th root of 2,000 divided by 1,200 equals 1 plus I. When I subtract 1 from both sides, I get 8th root of 2,000 divided by 1,200 minus 1. If I put that into my calculator, there is a button for doing any root that you want under the Math menu, but it's also pretty easy. I could do 2,000 divided by 1,200, put that in parentheses, and then raise that to the 1/8 power, because a 1/8 power is the same as an 8th root. So when I do that, I get that the interest rate per period is 0.0659 or 6.59%. That corresponds to an annual interest rate that's 4 times as large. So 4 times 6.59% is 26.36%. Remember, the I is the interest rate per period, and you'll have to multiply that by however many times you're compounding in a year. In this case, we were doing quarterly.